we are going to officially look at Pascal's triangle. Pascal is a very famous mathematician, and here's his triangle. Okay, so you're going to start up at the very top with a 1. So every time you have a row, it starts with 1. The second row is going to have two numbers, 1 and a 1. The 1's always go on the outside. Okay, now things will definitely start getting a little more interesting. We start with a 1. There's two numbers here that can combine. A 1 and a 1 can combine to make a 2. And on the outside, we always have a 1. All right, let's do the next row. Let's do row 3. We have a 1. I can combine these two numbers here to make a 3. I can combine these two numbers here to make a 3. And on the outside, we always have a 1. Okay. The next row has a 1. A 1 and a 3 make a 4. A 3 and a 3 make a 6. 3 and a 1 make a 4. And then you have a 1. Okay, every other row is going to have doubles in the middle. This one doesn't have doubles, but the next one's going to. 1, 5, 10, 6 and 4 make 10. There's my doubles. 5 and 1. 1, 6, 15, 20, 15, 6, and 1. Let's do it one more time. 1, 6 plus 1 is 7. 6 and 15, 21. Then we have 35. Oh, this is going to have doubles. 35. And then if you want, you could just kind of go back here and see 21 and 7 and 1. So a couple of notes about Pascal's triangle. Okay? This is row 2. The one with 3s is row 3. Okay, and that's how they call it. The ones with 4s is row 4. Very easy to remember. And then as you get up to the top, here is row 1, and what are we going to call that thing? That's called row 0. All right, kind of weird, but when I explain to you why we call it that, it's going to make a lot of sense. If I take x plus y to the 0 power, what do we get? Anything to the 0 power, that quantity turns into a 1. Now, what if I take x plus y to the first power? Then we get just x plus y. All right, let's get a little fancier here. I take the binomial x plus y to the second power. Now, don't say x squared plus y squared, people. Don't forget about your outers and inners. Perfect square trinomial plus 2xy plus y squared. Okay? And this is where you should stop and maybe notice some things. Okay, when you take a binomial and you square it, the coefficients are 1, 2, and 1. The coefficients come from row 2, just like that. Okay, so what is this triangle? What is this triangle? This is, all these numbers are the coefficients on expanded binomials. On expanded binomials. Okay? And so this is going to make our multiplying a lot faster, a lot easier. Okay? So let's do a couple of examples here. We've got x plus y to the 7th power. So what we're going to do, okay, this is what we're not going to do. This is the old way. We're not going to take x plus y and times x plus y times x plus y 3 times, 4 times, 5 times, 6 times, and 7 times. And we're not going to distribute an x and distribute a y and get an answer, and then distribute that x and distribute the y and then get an answer, and distribute. Add up all your like terms. Pray you don't make a mistake and get the answer. Okay? We're not going to do it that way. Here's how we are going to do it. We are going to use the 7th row of Pascal's triangle. Okay, 7th row. So that means we're using the ones with the 7s. How many terms are we going to have with the 7th power? Well, hang on. When it's the 2nd power, there's 3 terms because of outers and inners. So you got your middles there. So when it's 7 terms, we're going to need 8 terms. 1, 2, 3, 4, 5, 6, 7, and 8. So I like to get it all set up with the amount of answer blanks. Now, since it's the 7th power, we're using row 7th of Pascal's triangle, so the coefficients are going to be 1, 7, 21, 35, 35, 21, 7, and 1. Now it's time to take our terms. So the first letter we have here is x. Okay, so what we did when it was x squared, we had x squared, and then we went down to x, and then we had no x's. So we're going to start with x to the 7th power. So there's your first letter, your first variable. The next one is going to have x to the 6th, and they're just going to keep going down. X to the 5, x to the 4, x to the 3, to the 2, to the 1, to the none. No x's in that last term. Okay, but it's time to bring it on back. Okay, our other variable was y. So we're going to start down here with y. How many y's? 7 y's. 7, y to the 6, to the 5, to the 4, to the 3, to the 2, to the 1, to the none. In the beginning, we had 7 x's. The second term, there were 7 letters, 6 x's and 1 y, 7. X to the 5th, y squared also had 7. So the 7 is maintained, but as 1 goes down, 1 goes up, and you are done multiplying all the binomials. Wow, this is really fast. Let's try a couple more examples. 2x plus 3 to the 4th power. So we're going to need how many blanks? 5. 1, 2, 3, 4, 5. I'm going to get 5 blanks ready. Okay? You don't have to do that. I just like to kind of organize my notes for you a little bit. The first thing you're going to do is you're going to get the coefficients. When it says power 4, you use the row that starts 1, 4. So I know the coefficients are 1, 4, 6, 4, 1. Okay, but things are going to get a little more interesting here because my first term right here in the binomial is 2x. 2x. So I'm just going to put a note here. Use parentheses. I need 2x to the 4th power. So I'm going to write 2x in parentheses to the 4th power. Then I'm going to need to take that 2x to the 3rd power. Let's bring it all the way down. 2x in parentheses squared. 2x to the 1 to the none. Okay, and we're going to bring it on back now with, threes. Threes, a plus 3, a positive 3. Okay, so that's going to be 3 to the 4th. And it's times 3 cubed times 3 squared times 3 to the 1 times 3 to the none. Now, there's a little bit of work here we're going to have to do. I'm going to have to clean these all up. 2x in parentheses, quantity to the 4th. So the x is going to get the 4th power, but so is the 2. So we're going to have a couple things happen here. 1, I'm just going to write these coefficients down again. Okay. Now I've got 2x to the 4th. So 2 to the 4th power is going to be 16. And then that's going to be x to the 4th. Now let's take 2x quantity cubed. What's 2 cubed? That's going to be 8x cubed. And then I have times by 4x squared times 2x. Okay, and now it's time to clean up those 3's. Times by 3 is just a 3. 3 squared is 9. 3 to the 3rd power is 27, and this is going to be 81. So we are now officially ready to put everything together to make the final answer. Okay, so do not try to jump all the way to the end at once. 1 times 16x to the fourth is 16x to the fourth, plus 4 times 8 times 3. Put all those numbers together, and that's 96x cubed, plus 6 times 4 is 24 times 9, 216x squared. 4 times 2 is 8, times 27 is again 216x plus 81. So we just expanded that binomial by using Pascal's triangle and the technique of the powers going down, down, down. Okay, I got one more example here for you. And the only difference is there's a minus sign. And subtraction is the same as adding the opposite. So that 2 is actually negative. Okay, since the power here is the 6th power, we need to get Pascal's triangle, row 6, and so that's going to make 7 terms. So let's get 1, 2, 3, 4, 5, 6, 7 terms ready. I'm going to write the coefficients out, and I know they're going to start 1, 6, but I will look up here at Pascal's triangle to help me out a little bit. 1, 6, 15, 20, 15, 6, and 1. Okay, so Pascal does make things a lot easier. You will have to write out the triangle, though, in a test or quiz in order to use his triangle. All right, the first thing we have is y. So let's start off with y to the 6, to the 5, to the 4, to the 3, to the 2, to the 1, to the none. And then we have to bring it on back with negative 2's. Okay, negative 2 is very important that we use parentheses because there's negatives. So starting down here, it's negative 2 to the 6th. Now that negative is going to cancel out. But here, negative 2 to the 5th, that negative is going to stay. So parentheses are very important. Negative 2 to the 4th, negative 2 squared, negative 2 to the 1, to the none. And now it's just a matter of, can you do some numbers? So we have y to the 6th plus 6. Wait a minute. 6, 5, 4. Uh-oh. This was supposed to be to the 3, to the 2, to the 1, to the none. Did you catch that? Oops, sorry. How come no one told me? Okay, so this is actually minus 12y to the 5th. I was just getting ready to tell you, when you have a negative number, every other one is going to be negative because the next one has an even power, and so that's going to make it positive. So just look out for the every other one being negative. That's how I caught my mistake so early. 4 times 15 is going to be 60y to the 4th. Here, this one's going to be negative 20 times negative 160 y to the 3rd. This one's going to be positive 15 times 2 to the 4th is 240 y squared. This one's going to end up being negative, right? Okay, go ahead and calculate. Negative 192y, and this one's going to be positive, right? Plus 2 to the 6th power is 64. So spend some time organizing using parentheses, but this is the fastest way to expand binomials. Pascal's triangle.